Welcome, ladies and gentlemen. So what I like to do is show you how to graph two rational functions. And basically what we're going to do is, again, just follow our 7-step process. And just a kind of reminder, when I get through my 7-step process, step number 6 is plotting points, and step number 7 is actually graphing them. But the main important thing is we're going to identify our major components of the rational function, meaning we're first going to test for symmetry. Then we're going to go ahead and find the Y-intercept, X-intercept, vertical asymptotes, horizontal asymptotes, and then determine points to left and to right of those vertical asymptotes and use symmetry to be able to graph the line. So the first step we want to do is, I'm going to go through this again since I've already kind of gone through this slower. I'll try to work through these a little bit quicker because they do take a little bit of time. So the first thing we want to do is go ahead and test for symmetry. Remember, to test for symmetry, we're going to plug in f of negative x. If we obtain the exact same function out when we plug in negative x, then we have symmetry about the y-axis. If we obtain the opposite of the function, the negation of it, then we have symmetry about the origin. So when I go ahead and simplify this, I obtain negative 2 up top. Negative x squared is a positive x squared. Minus a negative x is positive x, and minus 2. So it's very close to being the same equation, except my, oops, that's an x. Except my x is here positive, where in the numerator it's negative. So therefore, it's not a whole negation of the function, nor is it exactly the same. So therefore, unfortunately, we cannot use symmetry when we are graphing, because there is no symmetry. Step number 2 is identifying the x and the y intercepts. So basically, the x-intercept, remember, is when y equals 0. The y-intercept is when x equals 0. So the first thing is we'll find the y-intercept. So to do that, we're just going to plug 0 in for x. So f of x represents the y value. Basically, it's the f of x axis, or the y value. So we're just going to plug in 0 in for x. So I have 0 squared minus 0 minus 2. OK, so when we go ahead and do this, we get negative 2 divided by negative 2, which equals positive 1. Y-intercept is positive 1. Negative 2 minus 0. Oh, minus a negative, that's going to be, I'm sorry, minus 0, so that's going to be minus a negative, so it'd be positive, because that should be negative 1, if I remember. Yeah, it should be positive. No, negative 1. The y-intercept, negative divided by negative, is going to be a positive 1. X-intercept. So the x-intercept is basically we're going to make our y value, or our f of x, equal to 0, and then solve. So I have negative 2 divided by x squared minus x minus 2. Now this one gets students, again, all the time. So remember, whenever you're solving for x in this case, you're going to multiply by the reciprocal. So I have x squared minus x minus 2. And so you just multiply by the reciprocal of your fraction on both sides. Well, that goes to 0. That divides to 1. And you're left with 0 is equal to negative 2. Well, 0 does not equal negative 2. So there is no x-intercept. OK? Step number 4. Now we need to determine the vertical and horizontal asymptotes. So the first thing we'll do is we'll determine the vertical asymptotes. Now remember, when determining the vertical asymptotes, that's going to be where the graph crosses. That's going to be where the graph crosses the x-axis. So I just don't understand. Crosses at positive 1. Let me just graph this real quick as I'm going through this. So the vertical axis, so we're going to set our denominator equal to 0. So I have x squared minus x minus 2 equal to 0. Now we go ahead and factor this. What two numbers multiply to give you negative 2? Add to give you what? Positive 1. So that's going to be x minus 2 times x plus 1 equals 0. Go ahead and set them both equal to 0 and solve. And I get x equals 2 and x equals negative 1. So those are going to be my two vertical asymptotes where the graph is not going to cross. And then what I'm going to do is determine the horizontal asymptotes. So to determine the horizontal asymptotes, we're basically going to look at the degrees of both of these. And you can see that there's no degree here up there. But there actually is a degree. It's actually x to the 0. So remember, we're comparing our degree in our numerator compared to our degree in our denominator. Well, the degree in our denominator is greater than the degree in our numerator. So whenever the degree in the denominator is greater than the one in the numerator, then we have a horizontal asymptote at y equals 0. So now the last thing we need to do is go ahead and graph. And I'm going to cheat and use my calculator just to check one thing here. Yeah, positive 1. OK. Just want to make sure I had that there. So therefore, we're good to go. OK. So now we go ahead and graph. But what was the first question that they're asking? Because they said, oh, they didn't ask. Huh. That's interesting. OK. So we have asymptote, asymptote, asymptote. So we're going to first plot all of our asymptotes. So we have an asymptote at -1, and we asymptote at +2. So we're going to create our nice little vertical lines here. OK. Oops. Let's use red. It's much easier to determine what the asymptotes are compared to the graph. So I'm going to use red. So we have one at -1 and at +2. We also have a horizontal asymptote at y = 0. OK? So now we just need to determine what, again, the graph is going to look like. So basically, the other point, I'm sorry, is we don't have an x-intercept, so the graph doesn't cross the x-axis. But we do have a y-intercept at +1. So basically, my thought in theory when doing problems like this is to go ahead and choose points to 2 to the left of each vertical asymptote and 2 to the right. Now, since there's no any symmetry, I'm going to obviously want to know what 1 is. Because I can't just find what's on the left side and then replace it on the right side. So I'm going to figure out, if that's 1, what is going to be at 2. So I'm going to figure out, just like you're going to create a table, I'm going to choose points here. Let's go ahead and pick -1, -2, -3. So I'm going to figure out -2, -3. I'm going to want to figure out what 1 is. And 1, 2, 3, and 4. 3. And 4. So therefore, that hopefully should give me enough vision of what the graph looks like. So again, to find those values, basically what you're going to do is plug them all in into your function and then determine what the value is going to be. F of 3 and f of 4. So basically what I'm going to do is I don't have enough time, effort to show you plugging them all in, so I'm just going to talk my way through it. So if you plug this in, you get -2 squared, which is +4, minus a -2, which would be adding 2. So that'd be 6. Minus 2 is 4. So it's basically -2 divided by a +4, which equals -1/2. So at -2, 1, 2, I'm at -1/2. So that's going to be halfway there. Let's go to what -3 would be. At -3, that's going to be 9 minus a negative would be adding 3. So that's going to be 12. Minus 2 is 10. So that's going to be -2 over 10, which equals a -1/5. So that's going to be getting closer and closer to 0. OK? Let's go ahead and do 1. 1 squared is 1. Minus 1 would be 0. Minus -2. So -2 divided by -2 is going to be a +1. So that's going to be exactly the same. Then let's go ahead and check into +3. So I do 3 squared, which would be 9. Minus 3 would be 6. Minus 2 would be 4. So it's -2 divided by -2 divided by 4, which is going to be a 3. 3 is going to be 9. Minus 3 would be 6. Minus 2 would be 4. So -2 over 4. So -2 over 4, which equals -1/2. And then do f of 4. So that's going to be 16 minus 4, which would be 12, minus 2, which would be 10. So -2 divided by 10, -2, -2 divided by 10, -2 divided by 10, -2 divided by 10 equals -1/5. OK, so let's go and plot those. So here I have 1. And then at 3, I have -1/2. And then at 4, I have -1/5. OK? So to grab the shape, remember when you're plotting, so that's like step number 6. Step number 7 is now to converge them on your asymptotes. So remember that each of these asymptotes, our lines are going to approach them. So it needs to approach this asymptote and approach that asymptote. So I'm going to draw a nice little curve here. Here, these two both need to approach their asymptotes. They can't approach going down because that's kind of like a dead end. So I'm going to draw a nice little parabola there, and then I'll draw another curve here. OK, so now let's go and get into this example. So now, again, we're going to do the exact same thing. First thing is identify symmetry. So identify symmetry, I'll do f of negative x. When I do that, I get 4 negative x squared over negative x squared plus 1. That gives me 4x squared over x squared plus 1. So you notice I get the exact same function back. So therefore, this is symmetrical about the y-axis. Meaning, over here, I couldn't just pick values to the left of the y-axis and then just reflect them. What I had to do is I had to pick 2 points to left and right. But now that we have symmetry, I can just graph one side of the graph from the y-axis and then reflect it over. Step number 2. On step number 2, I need to determine the y-intercept. So again, what I'm going to do is I'm going to plug 0 in for x. So I have f of x equals 4 times 0 squared over 0 squared plus 1. Well, that becomes a 0. Over 0 plus 1 is 1, which equals 0. That means the graph is going to cross the y-axis at 0. Next thing I need to do is determine the x. That's the y-intercept. So now to determine the x-intercept, again, I'm going to plug 0 in for f of x. So 4x squared divided by x squared plus 1. Again, just like I did over there, I'm going to multiply by the denominator on both sides, x squared plus 1. And hopefully you kind of get the idea here. You're going to get 0 equals 4x squared. Well, obviously, if you're going to go ahead and solve for x, divide 4 on both sides, take the square root of both sides, you're going to get x is equal to 0. So we have the y-intercept, y equals 0. The x-intercept, x equals 0. Now we need to determine the asymptotes. So to determine the vertical asymptotes, again, we're going to set our denominator equal to 0. So I have x squared plus 1 equals 0. Now when I go and solve here, I have x squared equals negative 1. You cannot take the square root of a negative number. So therefore, there's no vertical asymptotes. So that means the graph, there's all values in the domain are going to be a part of the function. Number 5, horizontal asymptotes. Now we need to use the horizontal asymptote test. So we look at our degrees here in this case. And you can see that they are equal. So that we can say is 2 is equal to 2. So remember, when we have 2 equal to 2, that means that y equals a over b. So a and b represent the coefficients. So a represents the coefficient of my numerator, and b represents the coefficient of my denominator of our leading terms. So that's going to be 4 over 1. So therefore, my horizontal asymptote is y equals 4. So now let's go ahead and graph. So we know that we have a horizontal asymptote at 4. 1, 2, 3, 4. We know that we have an x and a y-intercept at 0. Now we just need to determine what the heck does the graph look like. So to go ahead and do this, basically we just need to choose values. And again, I'm just going to choose, since we can use symmetry, I'm just going to choose what 2 values. I'm just going to use 2 values here, negative 1 and negative 2. Actually, you know what? Let's use, it doesn't really matter. So I'm going to plug in for x, negative 1 and negative 2, and determine the y values. So to plug them in of a function, I will plug them in here. But I'm not going to show work. I'll just talk my way through it. So we have negative 1 squared, which is positive 1. 4 times 1 is 1. Or 4 times 1 is 4. Then we have negative 1 squared, which is positive 1. 1 plus 1 is 2. So I have 4 divided by 2, which is 2. So at f of negative 1, we have the point 2. At f of negative 2, you do negative 2 squared, which is 4. 4 times 4 is 16. Negative 2 squared is 4. 4 plus 1 is 5. So we have 16 over 5. Now, again, when graphing and you have a fraction, I always like to just kind of simplify that so I know what the decimal approximation, which is 3.2. So you can see at negative 2, I'm getting 1, 2, 3. I'm getting a little bit closer to this asymptote. All right, so it has to approach the asymptote. So it's going to look like that. But then it has to touch here. Right? It has to cross the x-axis. Now, again, we can use symmetry to just basically reflect these 2 points and then redraw our graph. So there you go, ladies and gentlemen. That is how you graph a rational function using your 7-step process. Thanks.